Hello everyone. I'm Andy from ThinkMo. Now I am teaching CCIE course. Starting today, I will share with you some CCNA, CCNP, CCIE related technologies. Our topic today is Network Device Virtualization Technology, Stacking. First, for stacking, need to be clear. It is applied to a technology on the switch. Next we will what is the first stack? What is the benefit of stack? The third stack usage scenario. In Huawei's system divided into two. One is CSS, called Cluster Switch System. It's virtual chassis system. Huawei usually calls it a cluster. Of course this cluster. Not what we mentioned. On the server. Application-specific clusters. It is mainly aimed at mid-range and high-end modular switches. For example, we mentioned CE series switches. Then there is the iStack. It's called Intelligence Stack. It targets a boxed switch. So what's the difference between the two stacks? First, CSS is mainly used for mid-range and high-end modular switches. He supports the stacking line. Stacking card can also support business. For box switch stacking, commonly used stacking line plus stacking card. You can understand it is a dedicated stacking line. So what the heck is this stack? First, for CSS, mainly to connect two frame switches. To stack virtualize as a device. Then carry out unified management. And some other functions. We all know for box switches, its interface and performance aspects probably not as good as a frame switch. Then in this case for this box switch, we should expect it supports more stacks. Multiple units can be made into one. This is what we say iStack smart stacking technology. Then let's explain advantages and disadvantages between them. First, CSS can support business ports. That way we don't need by stacking wire separately and stacking cards. Both of them are more expensive. For such a situation, CSS can use business port to stack, such as optical fiber and network fiber, can be connected directly to make a stack. Virtualize it as a switch. Usually for some 77 series S-series switch. In fact, it also supports business interface docking. Not all are. It's generally the case. We have to go alone by stacking cards and stacking lines. So for iStack, the advantage of it is that it is cheap. Cost of box switches definitely better than the mid to high end. The price of the frame switch is cheap. At the same time it supports interface may be more. For box switches, mainly used for access environment. This is what we refer to as stacking. Then we put multiple devices after virtualizing into a device. What is its benefit? It mainly has the following advantages. The first is to simplify configuration and management. What is simplified configuration and management? Let's take iStack as an example. For example, there are 6 switches. After you have access to them, you have to switch unified management. Then you fail, possibly when configuring, either via Telnet or SSH, or use the control line directly. For configuration management, all need to log into on multiple devices or log into a device. Then Telnet or SSH, another device. It's more troublesome. The stacked devices become one. Since it is these other switches, it is equivalent to the interface of this switch or interface board. In this case, what you see when you go up is the entire management plane. What is the whole management plane? That means I just need to log in. Any of them. Switch can see the entire docking system, the entire management plane, such as interfaces or the configuration we see on any switch. Configuration made on other switches. Can see. Can also be distributed. Just another switch. Can also be synced to this configuration. This is the first benefit. Second benefit. Between the equipment redundant backup. For example, multiple devices are stacked into one. When one of the devices malfunction, for example, the line is interrupted, or the device is powered off, this does not affect the normal business transformation. Secondly, it involves load sharing of traffic. It is mainly to combine F-trunk. Function to use F-trunk is called link aggregation. It is done by putting ports on multiple switches tied up, ports that form logic. Achieve this load sharing of traffic. Here we introduce a concept. Often there is a place for stacking. Must have F-trunk without F-trunk. The role of stacking. Not too big. Specifically, we will explain accordingly. The fourth aspect is to improve the utilization of the link. What is it like? We all know if multiple devices interconnected, a loop will be formed. Then when we put these switches give it, after virtualizing into a device, then combine with F-trunk, connected to the access device, or upstream aggregation, or on the core device. I can because of how since multiple devices are virtualized as a device. In this situation, other equipment is equivalent to interface on the entire device. I can bundle these ports, then do an F-trunk with the upstream, form a logical port, so we can achieve load sharing of traffic. Also improves link utilization. Why improve link utilization? If not stacking, multiple devices can form a loop. This will intervene STP spanning tree. Then come break the ring. In this process, we don't need using spanning tree. The third aspect. It's a stacking usage scenario. It is mainly divided into two. The first is the campus network. The campus network uses the most stacking. Then for the campus network, or the access layer can also switching at the access layer. We mentioned switching at the aggregation layer. Even some cores are using for the data center. Basically no stacking, if necessary, are used in the access layer. Why is it said that it is only used in the access layer, not at the aggregation layer? Because stacking can occur. High failure rate inside the data center. Put a lot of virtual machines. There are many tenants for the server, mainly for others to visit, including the current Baidu's server, Taobao server, or WeChat. Have the servers we mentioned. These servers are located in the data center. That is to say, the data center to avoid as much as possible failure rate. So this is the data center. Reasons not to stack. So why use it at the access layer? Because the access layer it for high density. The server may involve multiple lines to achieve multi-line redundancy, etc., such as load sharing. We all know the server can also do load sharing. This is what we mentioned. Stacked usage scenarios. Mainly these two campus network generally uses stacking Because if the campus network is disconnected, or high failure rate. For data centers, it's not particularly important. The data center is at the aggregation layer, or at the core. Try not to use. That can have a high failure rate. We will also introduce later. Stack split, that is when a device loses power, or link failure, or on the switch. Usually in a data center. All used are CE series. This mid to high-end switch. Failure is not allowed. When a stack split occurs, or power outage, or line interruption, may lead to achieve timely switching, or interface, or card binding failure. Main control board failure. This situation cannot be achieved. Timely switch. Easily lead to data. What happens to the terminal? This concludes our sharing today. If you have any other techniques you would like to learn, welcome to leave a message or private message me. If you are interested in what I have to say, hope to like, share, and subscribe. See you next time.